out a quick little water jack here. Let's see, first of all I'm going to define a plane. So let me exit out of my sketch. Notice you can work with flat planes or planes on angles. You can work with whatever geometry you may create to have the water line walk along. Put in an offset perhaps a 2.5. That should drive it deeper into the B retainer that you see here. And that will become our sketch plane. So again, let's flip this to a top view. And I'm going to add some references so I know right where that pocket is at. Okay, you'll see why I did that. Now I'm in the sketcher. We're going to lay out the water lines. Take the water that goes through the whole plate, the plate and the insert. We'll do both at the same time here. Notice I am making a separate line as I come off the insert in a second. Next, we want to dimension this. If we dimension it, we then have the ability to go back and change those dimensions. What's nice too about water lines is they can be saved as a sketch. So if you have a water line pattern that you can save it and then bring it in again to another job and just simply change these dimensions. Once it's in pink, that means it's fully that's going to be our water line. Okay. So let's go and build the jacket now. With this too, you can do more than one plate. You can do all the plates through the old base at one time so that you can get a visual look of the entire jacket. Globally, we'll adjust the values like you see here to see the different sizes. Maybe with a 5/8 water line, I'm going to check to see how close is it to that screw. The visual analysis shows the areas that the water line breaks through with the insert. But how close is it getting to that screw? Let's see if there's 100 thousandths of material between it. Yep, so far so good. What about 200 thousandths of material? Now you see the screening that it's going to touch it. So it's not just a matter of missing the screw. If that water line is within a few thousandths, that's still no good. We need enough to make sure that it's going to be durable and be safe. So this shows us the minimum material condition that we need for that. Now with drawn this water line, we have the ability to set the different sections of it with different values. So in this case, maybe I want to make outside so that I can make clearance for whatever component I'm putting. And we build the water line, we're treating it as a solid component, which means we can go back and edit it at any time. Also, we have the ability to adjust the drill body. Here you can see in the corners they're being extended. That all gets checked too for collision. So let's build that water line, and that will go through the insert and through the plate like you see here. So intelligent water lines, intelligent placement of components. Now we want to show you something unique to placing a component, especially the ejector pins, that is. Those hide everything in the A half that we've been working on. Toggle over to the B side, and let's turn on the ejector system. And I'll turn the ejector plate off so that you can see exactly what it's going to do here. So I've got the retainer, got my B side inserts. Going over to the ejector tools, let's grab some ejector pins. Again, they're based upon whatever your catalog is. Please take these components out of a catalog, modify them, put them right back into a catalog too, if you want to customize them, if you want to change the overall hole size. Up pop this thing called, if I click on it, it's saying the rule is the ejector pin will be located off the back of the retainer plate. So that's one of the rules. With calculate length, define for me where it is from the back of that retainer plate then to the high point and the low point on the B-side surfaces. So it gives me the ability now to make a calculation so I can determine if I've got a long enough pin then to put into the assembly. So let's grab an ejector pin. We're going to place a few of these. Again, flop over to the top view. Hopefully that rotation doesn't take too long. And we're going to start placing them using the grid. So we'll pick a few locations. Maybe make that up higher, that looks better. Okay, that looks about the same. Good. Okay, so I've got, those are going through different places on those B-side surfaces, different slopes. Let's include them now. Next, we want to trim them. So what do we want to trim them with? First, we'll select them. Do we want to trim them with the fixed side or the A side, the movable side, the B side? Maybe I want to pick a plane or a surface where I'm going to trim them. We'll trim them by the B side surface. And then do we want them to be a flat trim that could be below the B side surface or above the B side surface? Or do we want to follow a shape trim, which is going to follow the slope? We'll pick shape trim. So that's going to cut the top off right where it would break out of the top of the B side. Something to point out is the ability to work with non-stitched data. Like you can see me flashing around here, you can see this different surfaces are being referred to. So those aren't stitched, but it's still trimming it back to those B-side surfaces. Next, we want to create some clearance on the ejector pin. So we'll grab the pins that we've been working with. Do this all in one operation here. And let's set some values. The L-fit value, how far down do I want the pin to? Let's say we want 400 thousandths of land on the ejector pin. And then we want the diameter to open up in clearance to 80 thousandths. I'm going to go through all 8 of those pins at the different levels where they've been cut. We can specify we want it to measure the land from the lowest point of the cut or from the cut or from the middle of the cut. Come down 400 thousandths and then open the diameter up by 80 thousandths for clearance. Okay, so there you see it. And for the sake of visualizing it, let's get into our clipping plane. We'll step over and see if we can hit an ejector pin here. There we go. So I'll zoom up on that and let you take a good look at that. You understand exactly what it's doing. Okay. So plug into the system to make sure that it's exactly what we want, what we'll be manufacturing. Okay. All right, so they've seen some of the basics of the design. Components are similar, and all the components are similar in how they're placed. That leaves us with the last item then on the wizard, which is the bill of materials. So let's take a look at that. We've been doing this. So all this information of all these components has been listed in the database, so we can select what we want to see on the output. It looks something like this. So you can see the parts that we brought in, the cavities, the core. You can see the standard components that came with the mold base, the standard plates, and also what catalog these. So an extensive and a complete listing in the bill of materials. Likewise, you can also see the components I added, the gib, the wood plate for my slider assembly, and now ×2